So this question is very similar to the previous one. A 20-sided dice rolled. Your first roll is free, and after each roll, you may either keep the value and stop or pay $2 to reroll, right? So we have to find out the expected value of the game under optimal play and the optimal betting strategy. So let's suppose that V is the optimal value of the game. V is the expected value of the game under optimal play, and we'd have, after the first reroll, we'd have numbers from 1 to 20 coming in, and let's say we have a certain threshold K below which we'd always accept the value, and below which we'd reroll, and above which we'd always keep the value, right? So in other words, my V minus 2 would lie between K and K plus 1, which gives my V as K. So my V would lie between K plus 2 and K plus 3, right? That's something within the setup that you have to note. So the expected value of the game, let's say, is V. Once again, using the formula for expected values, it would be nothing but 1 by 20 into the sum of the numbers. So you know that the value, each of the numbers before each of the numbers till K would be have an expected value of V minus 1, so that would be K into V minus 1 plus the summation from K plus 1 to 20 of X, right? X is any number above K. In that case, I'd have V equals 1 upon 20 into K into V minus 1, and once again using the N by 2 into A plus L formula for the sum of a series with difference 1, right? We'd have N as 20 minus K plus 1 plus 1, right? Divided by 2 into A plus L would be K plus 1 plus 20. So I have this. In the next step, I'm just going to put 20 on the other side. I have 20V equals K. V minus 2. This would be V minus 2 in this case, right? So I'd have, because the price for each reroll is 2. So KV minus 2K plus this would be 20 minus K into 21 plus K, right? That's what I have. And when I shift all the V's to one side, I'd have 20 minus K into V equals, I'm going to take this 2K in. What I'd have is 420 minus, so there's one minus K from here and 2K from here, which would be 1 plus 2 into 2, 4. So 5K minus K squared divided by 2, right? And the value of V would come out as 420 minus 5K minus K squared divided by 2 into 20 minus K. Again, in this case, we can't differentiate, but what we'll do is we will test with some values of K, right? Let's suppose I'm going to test it with, because for one reroll, when the reroll value was, when the price for reroll was $1, we got something between 14 and 15, right? I'm going to probably take it down a notch. I'm going to check with, let's say, something like 11. Let's say if 11, if that works out for us. So if K equals 11, then remember the condition, V would have to lie between K plus 2 and K plus 3. So if my V lies between 13 and K plus 3 is 14, then I have my answer, else I don't. So let's see if when K equals 11, V equals 420 minus 5 into 11 minus 11 squared by 2 into 20 minus 11, which would be 420 minus 55 minus 121 divided by 2 into 9. That comes out as 18 at the bottom. This is 176 and 44, so it would be 244 by 18, which comes out to be 122 by 9, which is roughly 13.555, right? And 13.555 satisfies a condition. It lies between 13 and 14. So in this case, this satisfies well. So therefore, P equals 13.555 is the expected value of the game, right? And so this would be the expected value of the game, and my strategy would be to my 11.555 is the net value of the game, right? Because you have to pay 2 for every reroll. So in this case, what I'd do is I'd reroll for 12. Sorry, I'd reroll for 11 and below. Right. Keep for 12 and I'd keep for 12 and above. Right, that would be the optimal strategy for this game. I hope the solution is clear. If you have any doubts, let me know in the comments below.